Alrighty, guys, we're going to continue on with our unit in similarity, and today we're going to talk about similar polygons. So the big idea for today is we learn what similarity is, what are the qualifications to check for similarity, and a similarity ratio, and also how to write a similarity statement. Okay, so let's start with our notes. Similarity is defined as when two figures have the same shape but not the same size. So you can kind of think about it as, let's see, you have like a smaller triangle and then a bigger triangle. It's the same shape, but they're different sizes. Okay? Now that's the informal definition. Now in math, the specific definition is this. You have to check for two things to say they're similar. So if two polygons are similar, we have to know that corresponding angles are congruent. So all the angles need to be the exact same size, exact same measure, and then the corresponding sides are proportional. Now we've talked about proportional yesterday when we talked about setting up proportions. If you set up, like say for example, this side matches up to this side in these two triangles. If you set up the fraction between those two and then checked this side to this side, that side to that side, that fraction should be the same all around. That's kind of what proportional means. It's hard to explain right now, but you'll see in a minute when I do the problem that it makes more sense. Okay, and then we have a similarity ratio, which is the ratio of the lengths of corresponding sides. Okay, and you'll be asked to find that on some problems today. Now, I forgot to point this out, but I'm gonna go ahead and point it out. This symbol right here looks like a little curly Q. That's the symbol for congruency. Or not congruency, I'm sorry, it's similarity. Congruent is an equal sign with that squiggle on top. That's congruent, which we've already talked about before. Similarity is just the squiggle, okay? Okay, these are the two important things that we're going to talk about. The corresponding angles are congruent, corresponding sides are proportional. So, on these two problems, what I've told you is this. We read this as LMNO is similar to HIJK. So this right here that is called the similarity statement. Okay, just like when you talked about congruent triangles, we had congruence statements. Now we have similarity statements. So what I've done is, well, first let's examine this similarity statement. So in this, notice that the order is important. Okay, so I'm telling you they're similar, so these two things apply. All right. So, for instance, angle L and angle H are in the exact same spot in terms of how the letters are written. That means that angle L and angle H are congruent. Okay? And then the side LM, so LM, and the side HI, those are proportional. So the fraction should be the same. All right? We can use this to answer these questions. So I'm asking you, who is congruent to angle M? So M, notice, is written second. So I'm going to go to the second letter in the next figure. So that would be angle I. So angle M is congruent to angle I. All right. So now we've got a proportion here between the sides. So notice I went M to N. So I'm going to try and do this like this. MN is proportional to IJ. So notice MN is the 2 in the interior. So is IJ. Okay. This fraction is supposed to be equal to a new fraction, but I've told you that the bottom is JK. So let's go back up here. Notice that J and K are the last two. So I need to use that same relationship or pairing in the first figure. So JK was the last two, so that means I need NO. So this question mark here would be NO. Okay, now that's the easy part, is using that similarity statement to answer these kinds of questions. All right, let me speed my paper up a little bit. So now we're talking about determining similarity. So now we have to check these two criteria, okay? So the first thing we're going to check is, are all the angles congruent? And then we'll check if the sides are proportional, okay? So are the polygons similar? We're going to check these two things. If so, write a similarity statement. So we're going to have to write this and give the similarity ratio, which I'll show you how to do. If they're not similar, we're going to explain why. All right. Now I chose this example specifically, and this is straight from your homework, so you won't have to complete this problem. But this problem evokes back to something we learned about isosceles triangles. Remember, isosceles triangles are when you have two sides that are the same. Okay? And I say that because the first thing I have to check is if the angles are congruent. Well, just from looking at the figure, I only know that one pair of angles is congruent. I know that Q is congruent to R. Okay? I have to have all three congruent. And so I bring up that isosceles point because if two sides are the same, then those angles across from them are the same. So I put two little arcs there to show that those angles are congruent. And then on the smaller triangle, notice that I have two sides that are 4 units long, and so I can say those angles across from those 4s are also congruent. Okay, so I'm going to write out angle M was congruent to angle N, and then, whoops, not N, excuse me, I'm going referencing the smaller triangle, angle S, and then angle N is congruent to angle T. Okay, so now we've got the first part checked. We've got corresponding angles congruent. Let me write that out. Corresponding angles are congruent. So now we have to check if the sides are proportional. So what we need to do, the best way I know how to explain this, is kind of match up sides between the two figures. So it helps that we're in the same orientation, everybody's pointed the same way. So what I want to do is, who matches up in the smaller triangle with this side labeled marked 20/3? QM is marked as 20 over 3. Well, in the smaller triangle, notice that the 4 is in that position. In that position. That means these two should be matching, or match up with each other. They're corresponding. So what I'm going to do, 20 divide 3, and then a big divide 4. Let me show you how to type that in. Do alpha y equals, and then go ahead and do another one. And then 20 thirds divide 4. That simplifies to 5 thirds. If you don't want to do it that way, you could also do it this way. Whoops. Make sure you put the thirds in there. And then, because this second fraction bar means division, we can hit divide 4 and also give us 5 thirds. Okay. Now, I know that if I do, let me do it in a box. So this side matches up with this side. I understand that that's the same work that I just did. I'm going to do it again anyway, because this won't happen all the time. You might have sides different lengths, and you'll have to check all 3 pairs of sides. Okay? So we'll do the other one. The next one. So I wrote 5 fourths. Look at me. All right, let's get this up a little bit more. The last pair of sides, whoops, I already used the box. Let's use something else. 5 to 3. And then we have 5, 3 as the final ratio. So notice, if you could simplify this fraction or expression, whatever you get, I want you to go ahead and do that. And then you have to check that all 3 of these fractions are the exact same. They have to be the exact same in order to have all the sides proportional. Okay? So we have corresponding sides are proportional. So we have fulfilled both requirements for similarity. So now they are similar, so we're going to write the similarity statement. So notice, you always generally go from left to right. So you start with whoever's on the left, go to whoever's on the right. Okay? However you write this first triangle determines how you write the second one, or polygon or whatever. So I'm going to go QMN. And then put my similar sign. You can just barely see that. Let's get that up. There we go. So QMN is similar. Now, because I went in that order, notice I went from Q to M, M to N, N to Q. I have to follow that same order in my second triangle. So I'm going to say triangle RST. Okay, and that's not the only similarity statement you could write. You could reverse the orders of the letters and it'd still be okay. You could say, you could go MQN is similar to SRT. That's another option. There's one more option, but I'm not going to write it. Now we need to get the similarity ratio. So the similarity ratio is, it's this 5 thirds, but I want you to write it like you did in middle school, like with the colon thing. So 5 to 3. Okay. So now I'm going to go back over this in a flash. So the first thing you have to check if all the angles are congruent. Each corresponding angle pair has to be congruent. That's what I was doing here. Then you have to check if all the sides are proportional. So in other words, when you set up your fractions between corresponding sides, They must come out to the same fraction like I got here with my 5/3. If one fraction is off, it throws the whole thing off. Okay? Then we wrote our similarity statement. There's another option for the similarity statement, and then our similarity ratio was 5/3. All right? So I'm going to do another one. Same idea. Now, automatically, I see something wrong. So, looking at the sides, I have the sides of the same length. That's not the issue I'm talking about. That just happened. The issue I'm talking about is the angles. This is a square, so every angle is 90, and that's marked for me. But look at these angles. I have 120, 60, 60, 120. This is a rhombus. The issue here is that the angles are not congruent. So angle K is not congruent to angle T. Okay, not every angle is congruent. So we say this is not similar because the corresponding angles are not congruent. All right, that's that. Now we're going to use the fact of similarity to answer some questions. Find some sides, okay? So I'm telling you they're similar, so you don't have to check for yourself. They are similar. What we're going to do is set up proportions like we did yesterday, matching stuff up. All right? So I always like to start where my variable's at. So I'm going to start here, x over 6, or x subtract 6, sorry, over. Now, go to the bigger triangle. Who is in the same spot as x minus 6? That will be 30. So I like to put that on the bottom. Equals, now you have some options here because they gave you every side. You could go, let's say you started with 8. So when you do small to big, you go back to the second fraction and do small to big. Okay? If I start with 8, then he corresponds to 40. If you wanted to use the 5 instead of 8, so you would have 5 over 25. You would get the same answer, just your work would look a little different than mine. All right? Now we're going to cross multiply. So x minus 6 multiply with the 40. This is one of those distribute situations, so I'm going to write it like a distribute problem. And then 30 times 8 is 240. Let's distribute. Now we have to solve it, so we're going to add 240. $480. Now we'll divide the 40. We get x to be 12. That's all you have to do. All right, same setup. Now this one's a little bit different. They're trying to trick you here, and I'll tell you what they're trying to do here in a minute. So I like to start with my variables. So 2x plus 8. Now go to the bigger figure. Who does 2x plus 8 match up with? It looks like it's going to be the 40. Now, in this instance, those are the same. But what they're trying to do is they're trying to get you to match this side up with this side because that's given to you. If you wanted to use this 9, you have to know this side right here. All right? You have to have them matching up in the same spots. We don't know that length over there, So I'm not going to use this 9. I'm actually going to use this top 9 right here because I know it matches up with the 15 and the bigger one. They're in the same spot. So I'm going to do 9 over 15. All right. First step is to cross multiply. It's another distribute situation. And then 40 times 9 is 360. Distribute. Now I have to solve this equation, so I'm going to subtract the 120. Gets 240. Now I'm going to divide by 30. And we get x to be 8. Right, there you have it. This shouldn't be too difficult. But remember to watch the video in its entirety before you start your homework. I will have the problems listed out that you have to do. And as always, if you need help, please let me know.